This is Professor Antonio S. Marahas, and this is Advanced Digital Technique. We go now to JK flip-flop. No? This is another type of flip-flop, which is actually the improved version again of your RS flip-flop. So there were some reconnection of your RS flip-flop, and because of that reconnection, or added connection I mean, the flip-flop was improved and they name it JK flip-flop. So whatever the circuit improvement, just do some research in Google or YouTube so that you will be able to find the improvement of an RS flip-flop, which becomes JK flip-flop. Okay? So what I will be discussing here is the operation of your JK flip-flop. So we have here the symbol of a JK flip-flop. We have inputs J, K, and outputs Q and Q bar. Okay? And then we have here the truth table, which represents the operation of your JK flip-flop. So you have inputs J and K again, then you have output Q, then whatever the output here will have a particular action. No? So these are your combinational values of inputs J and K. So if J and K are both 0, then again, your output Q is a no change condition, or the action is that whatever is the last state remains. Now, if J and K is 0, 1, then the output Q is 0. So if you notice here that J and K have different values, and J implies Q. Okay? So, the output 0 means that you are resetting your JK flip-flop. So, that means that the output 0, which is stored into your JK flip-flop, means that you are resetting your JK flip-flop. Now, if your J is 1 and K is 0, again, J implies Q, okay? Then you are actually setting your flip-flop into 1. Okay? That means that the stored binary bit in your JK flip-flop, the output part is your value 1. Now, if both inputs are high or 1, there is what we call toggle. What do you mean by toggle? Toggle means change to opposite state, or whatever is the last state will have to be inverted. So if, for example, if the last state is 1, then your input is 1, 1, then the output is toggle. Meaning to say, if the last state is 1, 1 is inverted, it becomes 0. If the last state is 0, then your input is 1, 1, then it will toggle. Meaning to say, 0 will be inverted, and it becomes 1. So that's what is meant by the word toggle. Means change to opposite state. Okay? So we will do some clarification on that later as we go along with our discussion, especially in the timing diagram part. So, let me discuss to you here the edge-triggered JK flip-flop with preset and clear. So, this is just like actually the same as that of your D flip-flop. Okay? So, but this time, instead of using D flip-flop, we're using JK flip-flop. So, in A here, the symbol for A, this is actually a positive edge-triggered JK flip-flop. Again, positive in the sense that the symbol here has a triangle, means positive edge of the clock. So this is a positive edge JK flip-flop with high, preset, and clear. Again, the value of your preset and clear should be 1 only. Walay value nga 0. Because as what it says here, high, preset, and clear. Okay? So we have here the truth table of your symbol A. So, for as long as clock is 0, regardless on the value of your J and K, whether it is 1 or 0, then the output is no change or last state. If clock is 1 again, regardless on the value of your JK, the output is still a no change condition. If clock goes negative edge, this one here, the arrow is going down, that is negative edge, if J and K again are 0 or 1, no, regardless of the value of your J and K, again, the output is a no change condition. However, if the clock goes positive, that is, arrow going up, no? So, if the clock goes positive edge triggered, then if you notice that this condition here, which is the same as this condition here, are obtained. In other words, this particular table is only true or can be applied in this particular symbol if there is positive edge triggering of the clock. Example, if you have positive edge triggered, 0, 0, no change. The same here. No change. If positive triggering, 0, 1, the output is 0. Just like this one here. 0, 1, the output is 0. Meaning to say, J implies Q. Since both J and K have different values. Then you have positive edge triggered, 1, 0, the output is 1. Then positive triggering, 1, 1, toggle. No? Here, 1, 1, toggle. So here, we consider the positive triggering of the clock. So toggle means, whatever is the last state, it will have to be inverted or complemented. Okay? So that is the table for this particular flip-flop. Now, this symbol here is actually the symbol of a negative edge triggered. Negative in the sense that there is already a bubble on the input part. So, negative edge triggered JK flip-flop with low, preset, and clear. Again, this is our truth table. If the clock is 0, regardless of the value of your JK, the output is no change. Clock is 1, regardless of the value of JK, no change. Clock is positive edge triggered, regardless of the value of your JK, no change yapon ang output. But if there is negative edge triggering of the clock, then again, this particular table here will be applied. No? So negative triggering, 0, 0, no change. Negative triggering, 0, 1, J implies Q. Negative triggering, 1, 0, J implies Q. Negative triggering, 1, 1, toggle. Okay, meaning to say, whatever is the last state, again, it is complemented. Okay? Now, the preset and clear here, if it is high, then that means that preset will have a value of 1. Okay? So if we will use again preset, that means that our initial Q will be equal to 1. However, if we will use clear, our initial Q will be 0. In the same way as in this particular case, you have low, preset, and clear. If preset is used here, preset should have a value equal to 0, so that your initial Q here will be equal to 1. But if you use clear, again, the initial value of Q here will be equal to 0. Okay? So that is our discussion for the JK flip-flop. Go now to the timing diagram using your JK flip-flop. So by the way, you might be asking in this particular discussion on why are we using timing diagram. So timing diagram actually provides us more information on how the JK flip-flop operates. No? So with the timing diagram here, we will be able to master the operation of a particular flip-flop. No? Whether it is D flip-flop or in this case, JK flip-flop. Okay? So what we have here in our first problem, number 1, is a symbol of a positive edge triggered JK flip-flop, but this time with low, preset, and clear. Okay? So, of course, we have output Q and Q bar. So what is needed here is to determine the timing diagram for your output Q and Q bar. Okay? So, again, this is positive edge triggering. So we have to consider only the positive edge of the clock. So we have here this one, the positive edge. This one here. This one, positive edge. Okay? So we know that during positive edge triggering of the clock, then there's a time that our table for the JK flip-flop are being used. So in this case, you have, let's say we will use, instead of clear, we will use preset. The preset should have a value of 0 so that your initial Q will be equal to 1. So that means that we will start, if this is your Q here, then we will start at 1. There. Okay? Now, let us consider the value of your J and K during the positive edge triggering of the clock. So here, you have positive edge triggered. J is, okay, so you have J is 1 and K is 0. So, we say if both inputs are different, then J implies Q. So, since we start at 1, and then J here is 1, and Q is 0, K is 0, then J implies Q. So, J is 1, that means that we still have a value of 1 here. Okay, then we go in this particular area. Okay, J is 1, K is 1. That means toggle. What is toggle? Change to opposite state, or whatever is the last state, you invert that. So since the last state is 1, then this becomes 0. Last state complement, or last state inverted. Then we go into this particular condition. Okay? Then if you notice that your J here is 0 and K is 1. So again, J implies Q. Since J is 0, then we remain at 0. Then we find again the positive triggering of the clock. Okay? Since during the negative triggering, the output is no change, so we have no change condition. Okay? And during 0 condition of your clock, no change. If during 1 condition of the clock, no change happen. So, we go directly to the positive triggering of the clock. So, in this case, positive triggering, J is 1, K is 0, J implies Q. So, your output here becomes 1, since J is 1. Then, in this case, we have 1, 1. That means it will toggle. What is toggle? Okay, 1, 1, toggle means last state inverted. The last state is 1, so it becomes 0. Okay, then we consider again this particular condition here. So, we have no change condition, and then negative triggering, 0, J is 0 because it's already going down, and then K is still 1. So, that means that J implies Q. So, since J is 0, it will remain 0 here. And then, until such time that we encounter again the negative triggering of the clock, positive triggering, you have 0, 0, that is a no change condition. Okay, based on your table. Then, this one here, positive triggering. Okay, you have 1, 1, meaning to say toggle. Toggle means change to opposite state. So, the last state is 0, this time it becomes 1. So, since wala na tayo positive triggering, then it remains 1. That will be your output Q. So, what will be your Q bar? Q bar will simply be the opposite of Q. So, like that. Okay, so that will be your Q bar. So, this is our initial Q here, which is equal to 1 if we are using preset. But if we use clear, then that means that our initial Q will be at 0. So, we'll start here, 0 here, and then you find the positive edge triggering of the clock. We now have another problem here. Okay, so the symbol here specifies that it is a negative edge triggered JK flip-flop, this time with high preset and clear. Okay, so let's say we use clear this time. So since this is high preset and clear, so clear should have a value of 1, Therefore, your initial Q will be 0. Okay? And if you notice that we still have the same problem as what we have in the last discussion. Okay? So again, this time, since we are using negative edge trigger, the symbol says negative edge trigger, that means that we will be considering only the negative edge of the clock. Okay? So that is this one here. We have negative triggering, negative triggering, negative triggering. Again, negative triggering means the clock, which is the edge of the clock, which is going down. Okay? So, let's determine the output Q and Q bar. So, again, since we're using clear is equal to 1, our initial Q is 0, so we start at 0 here. And then we find the negative triggering of the clock. 0, J is 1, K is 1, toggle, meaning last state complemented or inverted. So since the last state is 0, it becomes 1. Okay? Then you have negative edge triggering. Okay? Then both again are 1, toggle. That means that the last state is 1. We invert that, it becomes 0. Then negative triggering, you have 0, J, K is also 0. Meaning to say, no change condition from your table. Then, in here, you have negative triggering. J is 1, K is 0, J implies Q. The values are different, so J implies Q. So, your output here becomes 1. Then, you find again the negative triggering of the clock. Okay, 1, 1. That means that toggle. The last state is 1, so it becomes 0. Then, negative edge of the clock. Both are 0. Now, if you notice that your K here is going down, so it is already considered as 0. So, 0, 0, again, no change based on your table. Okay, then negative triggering here. Now, since in this particular case, your K is going up, that means that your K is now 1 and J is also 1. That means that it will toggle. Okay? Toggle, last state is complemented or inverted, so it becomes 1. And then here, the last negative edge states that your input J and K have a value of 1. So again, it will toggle. Last state 1, it becomes 0. So that will be our timing diagram for Q. And the Q bar will be simply the opposite of Q. Like that. Okay? So if during our experiment, if we have these particular conditions, then this will be the output of your experiment. Okay? Ang sama ni siya nga part sa imong output sa imong experiment, that is your light emitting diode. Okay? So for this particular condition of your JK, this becomes your output. So in this case, palong siya, musiga, then for a certain period of time, gasiga siya, then mapalong, then for a longer period of time, palong siya, then musiga, and so on. So that is how you interpret the output Q using your laboratory in your laboratory experiment, considering the output Q of your, considering the light emitting diode, which is your output Q of your experiment.